Okay, so we've talked about input and output color space. Basically, input color space is asking you, how should you understand color? And so when we told Houdini that we want to load in, let's say that OCIO config file, we're saying, hey, Houdini, I want you to understand color based on the primary set by ACE's color space. And those primaries, again, is that triangle that you saw, which is drawn inside of the CIE diagram. So it's saying, okay, here are the colors that you work with. That will affect the lights, that will affect the ingredients that you send to the render engine. And this is why we do this, right? We want a wider range of ingredients to feed the render engine so that we get a better result. So that's one thing that is good to know. Also, output color space, just as a refresher, it means that this is the way something expresses color. So if you have a JPEG file, a TIFF, an EXR, those are all going towards a computer screen, a TV, a projector, all these different mediums, and you need to have a transformation happen so that they display properly on all these different devices. Once you understand this, the next thing to know about is scene referred and displayed referred space. And so think of it like this. If something is scene referred, then let's take an example of a camera shooting some footage. What that is saying is that this is the color information. This is the data that is unaltered in any sort of way. So light hits the sensor of a camera. Before the camera does anything to that data, that is the scene referred colors, right? So no codecs have been put on there. There's no transformations that have taken effect. This is just raw energy that's being captured by a device. And in the world of CG, this could be understood as the ingredients that you might feed a render engine. So that's scene referred. Display referred means any sort of manipulation you make after that. So if, let's say, we take a render in CG, right? That's scene referred data. It's just the raw information. And then we convert that to Rec 709 because that's what our monitors are trying to display. That Rec 709, those pixels are now display referred. So as you read about people talking about color theory and color management, when they're talking about scene referred and displayed referred, they're talking about those two things. Here's why this matters. We want to work on scene referred pixels as much as possible. In other words, if let's say I make a color correction to video footage, I want that color correction to affect the original signal that the camera had. Not the signal that has all the different color spaces applied to it and this and that, right? Not the signal that has this codec information going on. I want to find the data in its truest form and then bring that through a color correction. Or in the world of CG, what this means is that I want to feed the render engine the purest ingredients possible. And here's what this looks like in the world of CG. And this is probably where your workflow has been wrong for potentially years, okay? If you were making, let's say, a texture map in Substance Painter, just as an example, right? And you send that out as a JPEG. Well, that JPEG has an output color space, probably is sRGB, so it's designed to be displayed on sRGB monitors, that file is, right? And so, okay, you take that for your color and you feed that information to the render engine. Well, the problem is your render engine is also going to spit out a JPEG, which also has a color transformation happening so that this works nicely with computer monitors. So in other words, you've applied this sRGB correction twice. And that's why we have our clipped highlights. That's why we have those muddy grays. That's why we have a improper workflow. And when we go to light our scene, we're not lighting this properly because of the fact that we're not feeding the render engine this scene referred information, the scene referred, it's not pixels, but scene referred information from the application. We'll talk about common areas of confusion when it comes to this topic in a future video, but I do want to mention right here that when people talk about using a linear workflow in CG, what they're saying is that you want to calculate things on scene referred information. In other words, on information that doesn't have any kind of color transformation happening on it. The original, the purest raw information of what something is. This is an area of common confusion because a lot of times people think that linear workflow is the same thing as ACEs, but it's not. Not at all, actually. What linear is saying is that you're just working on uncolor corrected information. Also, just for the record, linear is not a color space. And this is something that application developers get wrong. If you go to Nuke, if you go to Maya or whatever, you will see linear as a color space, but that's actually not true. Linear is often just something that counterbalances sRGB, so they just take the opposite of sRGB. But technically speaking, that's not correct because linear means the unaltered data, or that could also mean raw. You see, linear or raw is basically saying the same thing. In the next video, let's move on by talking about gamma and specifically sRGB. When it comes to gamma and the names of these color spaces, they get really weird. And so I want to talk about the history of sRGB as a good example. And we'll put a few more ingredients together before we hop into Houdini. So I'll see you then.